Okay, so this we studied in the last video. That now we are going to study about this unrepeatable read problem, read write conflict. So also known as inconsistent retrievals, inconsistent retrieval problem that occurs in a transaction. Okay, inconsistent retrieval problem. Two different values are read from the same database. For example, see here we are having two transactions, TX and TY. So first in time T1, TX is doing the reading the account data A. Okay, reading the data in T2. In time T2, what is happening? TY, transaction TY, read A, and it adds $100 for this account A, and it updates the thing. Okay, it updates the data. It updates read A. Write, once write operation is used here, it is updated in the database. Okay, so immediately in transaction 5, time 5, TX is again reading A. So now initial value is 300 and final value is 400. So the database, it gets confused. It leads to inconsistency. So now it in transaction X, two values are there for A. Okay, one is 300 initial value, and now is the read value is 400. So it leads to inconsistent data due to the reading problem, read write problem. Okay, unrepeatable read problem. This one. Now, in order to overcome these three problems, we studied here. Okay, what are the three problems? Lost update problem, dirty read problem, unrepeatable read problem. So, in order to overcome these conflicts, we are going for concurrency control protocol. So, first one is the protocol. First one is the lock-based concurrency control protocol, timestamp concurrency control protocol, validation-based concurrency control protocol. So first we can study about the lock-based concurrency control protocol. So lock means it is once transaction is completed, until that the transaction is locked through a mechanism. So lock is a mechanism to control concurrent access to a data item. Okay, so there are two modes here. One is the exclusive X mode and another one is the shared S mode. So exclusive S mode, it is denoted by lock X instruction, and shared is given as lock S instruction. So what is exclusive X? Data items can be both. So after giving this lock, this read write, both the operations can be done. Okay, in lock X. But in shared, only read operation can be done. But in shared, only read operation can be done. This is the two things in lock-based protocol. We can see using an example. See, for example, performs locking. This transaction perform locking. So when we use lock S, only read operation can be done. Now we are unlocking. Now we are lock S of B. Okay. Now we are reading the B. So unlock B, we are adding A plus B and gets the result. In between, interleaved operations cannot be done. Okay, so this is the thing about the lock-based protocol. So locking protocol, see, locking protocol is a set of rules followed by all transactions while requesting and releasing lock. Okay, locking protocol restricts the set of possible schedules. It gives more restriction. Okay, so see here, consider here using lock. We are doing the transaction. First lock X. Lock X, it allows both read operation as well as write operation. Okay, so it is locking the account A first, B. Okay, account B. See, lock the account B. So this B cannot be, unless it releases the lock, it cannot be used in transaction 4. Okay, so this B account cannot be used here. So lock B, lock X B, read B, then B is equal to, from B detecting 50 rupees, then writing B, updating. Okay. Now after it releases the, after it does the read after updation, till that this transaction cannot use this B. Okay. Now it log yes. Yes means it can only read. Okay. See, read operation can only be performed. So it reads A and it logs B. Okay. Now logs A. See this. So this leads to the T3 nor T4 can make progress. Both are logged. Log B logs A. Okay. So executing log SB causes T4 to wait. Yes, executing log SB, it makes the T4 to wait. Likewise, T4 to wait for T3 to release its lock on B, while executing lock X of A causes T3 to wait, okay, for T4 to release its lock on A. This situation is called as deadlock, okay. So locking, so after completing a transaction and releasing the lock, then only other transaction can use that data. So this is the concept of lock, okay. So next protocol is the timestamp based protocol. So each transaction is issued a timestamp. Timestamp means time. It is when it enters the system. Okay. Always there is a condition that old transaction TA has timestamp. Old transaction TA. Okay, so if a old transaction TA has timestamp TS, this is timestamp TS of TI, and new transaction TJ is assigned timestamp TJ such that always TS of TI that must be less than TS of TJ. This is the condition here. Okay, this is the condition. TS of TI, that is old transaction, is it is less than TS of TJ. The protocol manages concurrent execution such that the timestamp determines the seriability order. Here the timestamp determines the seriability time using a timestamp. So in order to assure such behavior, this protocol uses two timestamp values, that is write timestamp and read timestamp. All write timestamp, it is a value. Okay, it is the largest timestamp of any transaction that execute what write operation successfully, or timestamp means it's the largest timestamp of any transaction that executes read successfully. So here the timestamp ordering protocol ensures that any conflicting read and write operation are executed in a timestamp order. So there are two conditions for read. It is given. So TI, that is old one. Okay. Always it must be, see, TI is always less than TS. So here TI of I, TS timestamp of I is less than this value. See, two timestamp values given. This is for read. Okay, timestamp issues a read operation. Then what happens if TS of I is less than or equal to write timestamp value? Then it does not perform the read operation. It is rejected and it is rolled back. If TS of TI is greater than write timestamp of Q, then the read operation is executed. Okay, so here execution is based on these two values, timestamp values. Okay, so here for write operation, what is happening? If TS of I is less than or timestamp, okay, two timestamp, it is comparing with two timestamp, that is or and write, read and write, then the value of Q, that TI is proceeding, was needed previously, and the system assumes that the value would never be produced. So the write operation will be rejected if it is less. Okay. Again, if it is less than the write timestamp, read the write operation is again rejected, and Okay. So here, what is happening again? Um, Again, the if it is less than the right timestamp, less than, then the right operation is rejected. Okay, a right operation is rejected and TA is rolled back. Otherwise, the right operation will be executed. This is the thing about TA issues a read operation and TA issues a write operation. This is the condition to be followed. Okay. The last is the validation based protocol. So in the validation based protocol, it is of three phases: read and execution phase, validation phase, write phase. Transaction I write only to temporary local variables, writes only to transaction TA writes only to temporary local variables. That is the read and execute phase. Validation phase, it performs validation test, okay, to determine if local variables can be written without violating the seriability. Then next is the write phase. Write phase, if TI is validated, the updates are applied to the database. Otherwise, TI is rolled back. Okay, these three phases of concurrently transaction can be interleaved, but the transaction go through three phases in order. This transaction is otherwise called as optimistic concurrency control. Okay, optimistic concurrency control. So we can see here clearly. So validation phase is also known as what? Optimistic concurrency control technique. So in validation protocol, the transaction has three phases. Again, I'm repeating once again. Read phase. Read phase means T is read transaction T is read and executed. It is used to read the value of various data items and store them in a temporary local store. Already we studied it stores the data in temporary, stores them in temporary data items in temporary local variables. Then what it will do, it can perform all the write, read, and it will store in a buffer, temporary buffer, and writes and stores permanently. Temporary variable is updated and stored in the, when we give the write operation, it is permanently stored, it is updated in the database. Okay, that is the thing here. Validation phase means the temporary values will be validated against the actual data to see if it is violates the serializability. Okay, validate whether it affects the locally temporarily stored variable, whether it affects the actual data. Okay, that it is checks. Then write phase, if the validation of the transaction is validated, then the temporary results are returned. If it is validated, it is returned to the database or system. Otherwise, what it will do, it will roll back the transaction. Okay, so these are the three phases. So first phase, read phase. Second phase, validate phase. So first phase, it reads and stores in the data items in a temporary variable. Okay, local variable. So after that, it once we perform write operation, then only it will be stored in the updated in the actual database. So what is validation phase? Once we are storing the data items in temporary local variables, we have to check whether it affects or violates the serializability, actual data serializability. So once after the validation phase, if it is validated, the write operation is performed and it is permanently updated in the database, or the system will be do the transaction, a rollback transaction. Hence, each phase has the following different timestamps. Okay, they have different timestamps. That is start TA, validate TA, finish TA. So it contains the time when TA start its execution, start TA. Okay, time. Everything is validated based on the time here. Okay, so we have already studied here timestamp. So validation, it is based on timestamp. Validation, it depends on timestamp. See, for starting, it gives a time. Validation, it gives a time. Finishes, it contains the time when TI finishes its write phase. Okay, this protocol is used to determine the timestamp for transaction for serialization using the timestamp of validation phase. See, otherwise, if it is validated, if it is not valid, it commit or roll back. Okay. Hence, timestamp of T is equal to validation of T. Okay. So validation, it depending on timestamp here. Based on time. So timestamp of validation phase. So the serializability is determined during the validation process. It cannot be decided in advance. It can be only done in validation process. While executing the transaction, it ensures a greater degree of concurrency and also less number of conflicts due to this. Okay, so each and every time it validates, and writes the database. Validates and writes. First read, it validates, then writes. So it due to this, there is only less number of conflict. So this is thus it contains transaction which have less rollbacks also. So that's all about concurrency control. We have what are the things we have studied. So concurrency means we have to study first what is concurrency, execution, then problems, read, write. Main operation is read and write operation. So when we are performing read and write operation like this, it may, if we are doing concurrent execution of a transaction, so it leads some problem, it causes some problem. Three problems are there: lost update problem, dirty read problem, then unrepeatable read problem. In order to overcome these problems, we are going for concurrency protocols. So there are three protocols: log-based protocol. So here using two modes, that is exclusive mode and shared mode. Exclusive mode only it allows both read and write operation, but shared mode, it allows only write operation. For that, there is an example. So if you are locking the data items like this, it leads to deadlock. This situation is called as deadlock. So next we are going for timestamp based protocols. So the transaction depends on two values, that is two timestamp values, that is write timestamp value, read timestamp value. So when we are going to perform read operation, if the timestamp of the transaction is less than this timestamp value, then the read operation cannot be performed. If it is greater than the timestamp value, read operation will be performed. So here, write operation, it checks both the values. So if the timestamp of I is less than this read timestamp, and if it is less than write timestamp, then the write operation cannot be performed. It is rejected. Okay. So otherwise, it will be the write operation will be performed. Validation means it has three phases: read, validate phase, write phase. So in read phase, what will happen? Local, temporarily storing the values in some buffer. Okay, local buffer. So now it is validating whether that particular thing will violate the serializability. If it is validated, we are going for write operation. That means permanently updating in the database. Okay, so this, you read this, and okay, thank you. That's all about concurrency control.